Ja, god morgon och välkomna hit till oss. Kul att ni är här via webben och här i rummet. Jag heter alltså Amanda Termén och är er moderator här under förmiddagen. Och vi ska inleda med ett företag som ni kanske känner till som heter SeaTwirl. And I think we're now switching over to English. Is that right, CEO Peter Laurits?
My name is Peter Laurits and I'm the CEO of Sitro. We are located in Gothenburg. And I'm really glad that we have the opportunity to tell you a little bit more about what we are doing and also about our marketplace. And thank you for listening in. So our vision is to become a world-leading supplier of floating wind farms. So we strongly believe that we have the technology and we have the team to make this happen. And becoming a world-leading supplier of floating wind farms is the key for the future, and we will be one of them. And I will say some things today that hopefully will make it clear that why we are going to be the supplier for that. And our business idea is to develop and produce and sell floating wind farm turbines. And our location in the food chain is that we produce and develop the complete wind turbine. So obviously we work together with a lot of bright and smart subcontractors and partners that has the expertise that we don't. And a typical customers for us in the future will be the developer of a wind farm. So that could vary, and I will get back to that later in the presentation. So the key thing is, why wind energy? Well, the main thing is that we have the global warming and we have the climate changes. So we need to reduce the usage of fossil fuels. And 70% of all greenhouse gases comes from energy production. And renewable energy, as long as the sun is shining, you will have wind and plenty of wind. So that's why we think it's the key component to reduce fossil fuels for the future. The need for energy is also increasing. Estimation is 50% or 60% by 2050. Most nations has also agreed to commit to the Paris Agreement. And there you have committed to reduce the greenhouse gases by 40% by 2030. And in Europe, the renewable energy is forecasted to be 90% of the energy mix by 2050. And that's a big number. And most importantly is that there is a cubic relationship between the wind and how much energy you can extract from the wind. So if it blows twice as much, you can extract 8 times the amount of energy. And well, that's what we are chasing, of course. The ocean covers 71% of the Earth's surface. That means that there is a lot of ocean out there. And floating structures can be placed at a much deeper water than the conventional offshore turbines. And there's tons of geographical areas where there are no location to build wind farms. And also the friendly out of sight. We want the energy from the wind, but we don't want to have the wind turbines in our backyard. And we can place them out, further out in the ocean, where we don't disturb people living close by. And offshore winds, the actual winds out there are more stronger and more frequent. So we talk about something that we say is the capacity factor. A capacity factor is the average power output divided by the maximum power. So how much energy is produced compared to its maximum. And if you take typical factors like onshore, you have a 30% perhaps. Near shore, 40%, but offshore, we are looking at 50%. And just imagine these turbines will operate for 25 years, at least. So having that extra capacity factor for 25 years makes a huge difference. So that's also what we are after. So it blows twice as hard, we can extract 8 times the energy, and also we can have a capacity factor which is much higher. And that makes a big difference. Okay, so now we get into why use our vertical solution. And we have a vertical axis wind turbine, and it's designed for offshore from the start. And that's important. A lot of solutions today are onshore solutions, which you place on a platform that simulates land. And it's a different environment out there. So we started with the ocean offshore from the start. We catch the wind from any direction. So we don't have to turn up against the wind. We don't have to pitch the blades, which means that we have less moving parts. And that means less things that can break. And yaw and pitch, which is called when you turn up against the wind and you move the blades, are one of the big problems when it comes to service and maintenance. And service and maintenance are more difficult out in the ocean. So we try to build robust and less moving parts and build it simple. We also have all the moving parts close to the surface. And this is a key factor. So we will show you on a video later that we have all the serviceable parts close to the ocean. So we don't need special vessels. We can use local labor or local contents going into the service contract, which is a big contract and important. We also have a lower tip speed ratio. That means that our blades are rotating slower than the horizontal. And also we have the same speed on all over the blade. So we have less blade corrosion. And that's also a big problem. It's we have the plastic that corrodes, that breaks, and over the years you have to do a lot of service and maintenance related to that. It also makes them more quiet. Now, maybe that's not a problem when you're out in the ocean, but we still like the idea of being quiet and out of sight. Another factor that is that the vertical solution scales better. And we have Sandia Labs, a research institute from America, concluded in a report 2018 that the vertical solution scales better, meaning that the design for vertical is easier to scale without getting into trouble with the construction or adding unnecessary cost. And why do you want to scale? Well, the ratio between scaling large and the output energy is very positive. So the larger you get, the more energy you get out of it, and the ratio for the cost is less. So it's positive to big, large turbines, which you might have seen. Another thing that came in that gave us a lot of courage was a report from Oxford Brookes University in England, and that was that the vertical solutions are more efficient in wind farms. Efficient means that they can create more energy and they can also be stacked closer together. But I will come back to that separate. That's a big news for us. Last and not least, when you have in the future energy systems where you have a lot of renewable systems, you're going to need support services. And support services is basically you get an energy that it's not always stable. Electricity is going to start fluctuating. And because we have a big turning mass, the whole unit turns together, we have a big inertia, and we can actually provide grid stability in the future. And we think that's going to be an important factor. Not today, but for the future. A few words about our solution. As I mentioned, we have a vertical axis wind turbine. The tower, as you can see, the white, is connected to the spar, which is the floater. And the floater works like a keel on a boat. And the tower and the underwater part, they rotate as one unit. And Michael, perhaps you can start the video. And as you can see the generator housing is moored to the seabed. The generator housing, the yellow part, I mentioned before, you can see we have the important stuff close to the surface. So again, you can access them quite easy with a normal vessel. You don't have to have a special vessel that you can access the top parts of the turbine. And the water carries the complete turbine, and this is essential. And that is what I said, we build for the ocean from the start. This reduces the stress on the bearing. And the bearing doesn't have to carry the weight of the structure. And it's not loaded by the tipping moment of the wind. When you get a lot of wind, the turbine wants to tilt in the other direction, and the bearing doesn't have to support that. And that means that we can build with lower the bearing and also have a lower center of gravity. And that's important for both for cost, but also for access for all the vital parts. Okay, a few words about the report that came out last year. The vertical solution is more efficient in wind farms, and this is big news for us. As the wind, just trying to explain, the wind approaches the front row of the turbines in a modern wind farm. You will have turbulence generating downstream, meaning that the turbines behind the front row will have a not so stable wind blowing through. And this is detrimental to the performance of the back rows. And this is called the wake effect. It's actually such a big problem that some of the really big suppliers of wind farms today have downgraded their future income, resulting in lower share prices based upon the wake effect that the back rows are not getting the output they expected. A team in Oxford, they showed that the wind farms could perform more efficiently if you substitute the horizontal solution to the vertical. The vertical can actually help and support each other and make each other more efficient. And if you arrange them in a grid formation, these turbines can increase each other's performance by up to 15%. And also you can place them closer together. And this is important because a wind farm developer, he wants to create as much energy in this location that he has bidded for. And if you can place them closer together, you can get more energy out of, and also you get less cable between them, and it's easier to access when you do service. Here's an example of the simulation that they did, 11,000 hours of simulation calculations, showing that the turbines are supporting each other instead of disturbing each other. So we will continue working with Oxford Brookes University and learn more and get further down this technology path. So the lowest LCOE, that's the levelized cost of energy on the market. It's our target. And it's the key. I think we can all agree that when we are back home in our house, we don't really think about where the energy comes from. We just want stable, good energy and not to a high cost, to a very efficient cost or low cost. So I repeat, we have designed for offshore wind from start. We are more efficient in wind farms, the vertical solution. We have a lower service cost, less moving parts, easier access to the important stuff. And it scales better, meaning that we can build bigger without having such an increase in cost. We can offer grid stability. And as I mentioned before, it blows a lot out there in the ocean. And we, SeaTwirl, we really believe that we have the right technology and the team to win the race for the wind farms. And obviously, together with our team and our partners, we will do our utmost to prove that we are right. Okay, a few words about our marketplace then. We feel like we are a bit of a center of a storm. We actually had 10-year anniversary 2 weeks ago. And when the company was started, it was less discussions about wind farms and offshore wind. Today, you have this discussion everywhere. So very exciting times indeed. A lot of nations has actually committed to targets that are very aggressive, and they try to do a fast track, meaning that it's going to be easier and faster to get the installation of wind farms faster. And just if you look at the presentation, you look at the US as one market, which the whole East Coast are being scanned and evaluated for different wind farm locations, and you have the West Coast as well. And US has committed to actually do a lot of infrastructural investments in the harbors and in the vessels. We have the Japan, which is a very dense populated island with deep water outside, where they want to get away from nuclear. And that is a brilliant place to place floating offshore. But also if you go to Europe, which gladly we see are actually taking a big step forward with UK's ScotWind as an example. They have had a request for proposal for 17 sites, and it's 14 winning consortium, and 11 of those 17 sites are floating. So obviously they are of great interest for us, and that's the market that we are looking closer to. And the area we are talking about, just to get a picture, is 7,000 square kilometers. Sweden has also announced, which we are really happy about, they have plans for offshore winds. They talk about 120 terawatt hours. So hopefully they can speed up, and we will stay very close to that offshore, of course, since that's extra interest for us. Okay, going back to wind farms, it's not the only place where you use wind turbines, of course. The reason that we are so interested in wind farms is that, first, we are a team here at SeaTwirl that wants to provide renewable energy to the world. So being able to do that, you need to get into the wind farms. That's where you have the big numbers, the big difference. That's where you can have a backbone delivery of energy to the system. And to be able to be a serious player for the wind farms, you have to build larger units, as I mentioned before. So that's our focus now. We are looking at scaling up, and we're also looking at what's the criteria that the wind farm developers would like us to have, so we are an interesting part for the future. Just to mention, we also have the local grid. That's more applications like remote islands. You have industrial applications like fish farms. You have oil and gas processes. And this is an exciting and very, as an engineer, you get excited because it's very cool solutions, but it also a lot of different work. You need to be a team that works with all different solutions, and the application process is different in each and every case. So it's quite difficult for us as a wind turbines provider to actually understand and work with the process. We obviously look into this, but it's more complicated, basically. Getting back to the team. The team obviously is the key factor. We have a dedicated team and who wants to change the future. We want to be able to provide renewable energy to the world. And we have a lot of experience highly educated, and we have a great team that is fun to work with, which is a key factor. And we've been able to attract talent from Spain, from Germany, Iran, from America, and we are looking for talent and continue doing so, especially now when we're looking out in Sweden and also outside Sweden for future customer applications. A few milestones. As I said, 2 weeks ago, we had a 10-year anniversary. So we were formed in 2012. 2015, we installed what we call our S1 unit outside Lysekil in the Swedish waters. And it's been operating really, really well. And it has given us tons of good feedback and also encouragement that we are doing the right design. It has survived different storms and harsh conditions without a lot of love and care. So it's been operating on its own, and that's what we want. Simple, robust solution. 2016, we were listed on the NASDAQ First North. And also another big milestone for us is that continuously over the year, we work with our IP rights, our patent strategy. And as you can see in the milestones here, we have received a lot of different patents all over the world. And we think that's a key factor for a company like us when we are going into the future to protect our developments. We also received in 2019 a grant from EU for 2.5 million euros. And that told us that we were on the right way, and it also helped us to support us in the future development. We also have carried out a few different rights issues. And again, we got great support from our owners that really wanted us to give us the financial support to continue our journey. So I want to thank you for that. And last but not least, we did a lot of work last year with our strategy. Few new members on the board, and the focus for wind farms are very clear, and it makes our job a bit easier. So that feels good going forward. I just want to say a few words about the development and the validation. I mentioned to the left, you see the S1 outside Lysekil. But also, obviously, we've done tons of simulation, analysis, calculations. And we have created a lot of simulation tools that can see and operate internally in the simulation world to make sure that our construction is going to work as we think. And you can also see the mold for one of our blades. It's built in Sweden, and you can see the size is quite interesting to see the people working on the blades. You get the proportions of what we are talking about. But getting back to the team, obviously they're continuously working on redefining the design. That means reducing materials, making it lighter, making it more robust so we don't have any future problems. But also simulation tools, and that's developed in-house with our team, but also together with expertise in Europe. And we did a very important tank test that we performed before Christmas, and we did that at Chalmers University together with the SSPA. And the results from the tank test were really great. It showed that our wind turbine is operating within the limits that we were hoping for. We had even been conservative when we did our simulation, so it operates better than we thought it would. So that was really good news. Just a few words again. The patent I mentioned before, since we have a unique solution that nobody else is doing, has been doing before. And now the different research is saying that the vertical is perhaps the way to go for the future. We are sure it's the way for the future. And Therefore, more and more people are listening in and looking into our solution, and therefore we will continue working close with our IP rights and patents so we can keep the momentum and keep our developments in-house. Okay, a few words, final words about our roadmap. We have the S1 in Lysekil, and it's been operating and is operating. We have the aim to install next year the 1 megawatt unit that we call the S2X. But then, obviously, we have the focus on the larger turbines. And you can see we have quite an aggressive time plan. And we need our strong partners. We need investors and support from our owners to be able to do this journey. But if we can continue doing what we love to do, we will develop and produce an SX for around 10 megawatt for 2025. And we will have an SX for 15 megawatt or bigger for 2027. And this is aggressive, but it's needed. And this is what the market wants. So this is what we're going to provide. So finally, I want to thank you again. We believe that we have the right team and the right technology to win the race for the offshore wind farms. And we will do our utmost to show you that we are right. Thank you so much for listening in. That's us.
Thank you so much, Peter. And for people that might be wondering, why are we talking in English? Is the world watching us somehow?
Yes, thank you. Yes, it's watching. Most of our customers, some of them are Swedish, but we have a lot of interest from America, from Great Britain, and from Japan as well. And it's so nice if we can have it in English, so we don't have to translate. So we can just send the video as it is.
Mm-hmm. That sounds like a good sign. And you just said that more people are looking into your solution. Can you describe a little more what's happening there? What kind of interest have you seen?
Yes, when the nations come out with the different proposals for the different fields for the wind farms, then you have the wind farm developers, the future customer of ours that go in and bid for a specific site. And when they have won the site, they go out and talk to people like us and say, what can you provide? This is the area we have. Would your solution be the right solution? So suddenly we get a lot of requests about future wind farms, if we could perhaps be the wind turbine supplier for that. Mm.
And as you said, you have a very unique solution, and it doesn't really look like how we imagine a windmill. So I'm wondering, can that also be a curse that people don't really recognize what they're seeing? And it's something so unique.
Yeah, absolutely. I mean, we are, as you say, we are a unique solution. And that, I have to say, that the support we got from the Oxford University, that the vertical is the way to go in wind farms, made a huge announcement in the market. And suddenly, I think that placed us even more on the map. So it helped us. Suddenly, somebody looked at this Gothenburg company a bit more. Mm. So.
And now we have very few moments left, but I want to ask you, what are the main challenges you need to overcome to make it big?
Main challenges would be that understanding the process of these different wind farm developments, so the nations actually can go ahead and make it happen. And we also need technical and financial support to do the journey. I mean, it's exciting times, but we still need support. We don't have everything in-house. So understanding the developments of the wind farms and getting support and expertise.
Okay, so we'll have to leave you there, but thank you so much and good luck on this exciting journey forward offshore.
Thank you.
Och